Stanford University.
Welcome to the seminar on People, Computers, and Design. I'm Terry Winograd, and quick announcement about next week's speaker, Anthony Lamarca, who's coming from Intel. He actually talked here previously a few years ago when he was at Xerox PARC. And he's going to be talking about a new initiative that Intel is doing, basically looking at ubiquitous computing with ubiquitous sensors. Right? We all know that we all carry devices with us that can sense all sorts of things. And interesting question as to how to make use of that in a good way. So that'll be next week, Anthony Lamarca. This week, we have Bjorn Hartmann, who, as with other speakers, I'm very pleased to say, was one of our students. Graduated a couple years ago and went to Berkeley, and has been starting up a lot of interesting work there. In particular, has moved into the area which we've had several speakers on this quarter, which is crowdsourcing. How do you make use of the fact that the net opens up this huge pool of people who can do things in a sensible way? And today he will be talking about some work they've done in that area.
All right. Thank you, Terry, for that introduction. It's good to be back at Stanford. Just to give you a quick overview, so today I'm going to be talking about crowdsourcing, but that is not all my research group at UC Berkeley does. So we do work at the intersection of three different sub-areas of human-computer interaction. That is crowdsourcing and collective intelligence, then some work that is closer to my own PhD work here at Stanford on tools for designers and developers, and sensing and physical computing. And over the last 2.5 years, we've built kind of a sizable body of projects across these different areas. And I'll be around this afternoon if you would like to speak about how to build better tutorials for people to learn design software or learn how to program, or how to build better prototyping tools for a new age of digital fabrication. Please feel free to track me down after this talk. For today, though, I'll focus in the kind of top right-hand corner of this diagram on tools for crowdsourcing complex work. Now, who in the audience does not know what Mechanical Turk is? Great, that's what I thought. So we can skip that slide. Here's my summary of kind of the state of the art today. We have the set of microtask markets, such as Mechanical Turk or Crowdflower or the Berkeley startup MobileWorks, which recruit from a large pool of unskilled workers online. And really, the mode of operation here is safety in numbers, right? You don't really know how well trained these people are or what their motivations are. So you just recruit lots of them and use redundancy and other quality control mechanisms to get good answers. There are important benefits. You can do a lot of tasks on these markets. You can get quick responses. Michael Bernstein, who also was a student here at Stanford, recently published a paper that shows that you can recruit people within 2 to 5 seconds on these markets with the right algorithms. And you can get lots of small tasks done. There are some important limitations, though. It's hard to find experts. Because if you have significant expertise, likely that will lead you to a job in that field, which means you're unlikely to spend lots of time online doing tasks for cents on platforms like Mechanical Turk. So the intuition here is that that places a hard limit on the kind of expertise requirements your tasks can have. Now, it turns out there are other ways of hiring workers online that give you that expertise. So one is freelancing. You just hire someone through the web. So Elance or Odesk do this. You have a number of applicants, and then you just hire the one that seems best suited for the task, and then you're in a normal kind of employment contract relationship. There's another model called innovation contests, like 99 Designs, Innocentive, Topcoder, which are kind of like Elance, except you get people to do the work ahead of time. And then you just pay the one person whose work you judge to be best. So if it's a logo, maybe we like this logo best. So these are closely related. The advantages here is you can find experts, and you can get them to do high quality work. And that work can be more complex. So in incentive, a task may be come up with this new drug compound or build a website for me. Flip side of that same coin is short tasks don't work. It's just not worth an expert's time and attention to do something for you for 30 seconds. And by the same token, because there aren't that many experts and you end up choosing one, that's how these markets are set up, you end up with low work volume. So that leads us to the following research question. How might we crowdsource complex work that requires expertise, but do it through microtasks? Well, other people have looked at that question. And so one standard way is to devise new algorithms that somehow marshal the contributions of multiple people to get to higher quality or more complex results. And so in particular, most of this work goes under the moniker of designing certain workflows or having design patterns of workflows. So find, fix, verify is one pattern that's pretty common now, which is you recruit different workers to find bad passages in text, another set of workers to fix them, and a third set of workers to verify that the text actually got better. And there are various variations on this general pattern. Now, I'm going to talk to you about three different approaches. The first one is to, instead of filtering out bad work, just improve the work that people are willing to do for you. So we're going to try to train workers and do that through feedback. The second approach is to actually take yet more of the work and give it to the crowd. So we're not only letting them solve a problem, but we're also letting them describe how one might solve a problem. And then the third project is going completely away from online markets, and we have a strategy to try to recruit expert workers in a physical space where they're already congregating. And of course, I should say that most of the work that I'm going to present here was done by my collaborators. In particular, some of them are here from Stanford. So the first project I'm going to present, the Shepherd system, was really spearheaded by Stephen Dow, who was a postdoc here and is now a professor at Carnegie Mellon. And then I have a large set of collaborators at Berkeley as well. And I see Matt Kahn in the audience in the back. He was an undergrad at Berkeley and is now a PhD student here in the department. All right, let's start with training. So a minute ago, I argued that there are these two clusters of systems: simple transactional platforms that target unskilled workers and expert platforms that recruit people with specialized skills. And so our question is, can we help the novice workforce improve their skill and kind of offer this trajectory towards the more skilled work? And I believe if we want crowdsourcing to become a viable part of the US economy, $2 per hour can't be the end goal. So how can we make crowd work and the people doing the work more valuable? So we believe that we can educate and motivate workers to do more complex work through process improvements. In particular, our hypothesis is that shepherding the crowd, that is, providing meaningful real-time feedback, will lead to better work and improve the worker's skills. So why might feedback be important? Well, there are a number of reasons that researchers have found. First, expert feedback can help people understand what the key metrics of a domain are and how to strive to improve those metrics. Assessment also provides motivation by making you cognizant that someone is judging your work. And third, there are many opportunities for social interactions, peripheral learning, when more than one person is engaged in this task. So to give you an example of what this might look like on a crowdsourcing platform, we've been asking workers to write product reviews. So something like this. This is a common task that you find on platforms today. It provides real value. It's needed in high volume. And importantly, it's a creative task. Right? So there isn't a closed form correct answer that you can check for. There's subjectivity in evaluation, but there are also known strategies for improving one's writing. So the concept here is we built a system called Shepherd, where workers write reviews a separate set of assessors see those reviews, provide feedback that gets shown back to the worker, and we go around the cycle. This is most of the task people perform of this short nature. There are many possible assignments of the task, right? So I cannot just only write one review. I could write 5 reviews for different products I own. All right, from the worker's perspective, here's what this looks like. We first show some basic instructions. What is this task about? And there are some guidelines for how to write a good review. They then write a review. And moments later, they will get feedback that looks like this. So they see what they previously wrote, and then there is this rubric that shows how somebody else judged their work. This includes a checklist of categories for how to write effective reviews, a scale, and also open-ended free-form feedback. I'll go more into how the system works in a minute, but first, how would we evaluate whether such an intervention has a positive effect on performance? Well, we set up a comparative study where workers in the no assessment conditions received no feedback. So that's the status quo. Just do a number of tasks. And then workers in the external condition receive feedback on each review that they write. Now, this is actually significant overhead, right? You may have potentially just doubled the amount of work that needs to get done for each review. So we included a third condition that just asks workers to self-assess how they did on the task. Now, our specific hypotheses were that first, assessment will help crowd workers produce better quality work. This is good for the employer. But second, assessment will also help crowd workers learn and improve their work over time. So this is good for the worker. Right? Potentially, this opens them up to more complex, higher paid work. And third, having assessment will also motivate workers to produce more output. And then fourth, all of these effects should be larger for external assessment, where there's an external expert involved, than for self-assessment. We used 3 measures. First, there's task performance. So an expert reviewed all of the, an expert assessed all of the reviews. Terminology can get a little tricky here. On a 9-point scale. To examine learning, we then looked at how those ratings progressed over time. So think about you have a sequence of these ratings, and then you do a linear regression and you look at the coefficient. It's the slope positive, negative, neutral. And then motivation, we gave workers the opportunity in response to feedback to change their review. And then we can measure, did they change it? How much did they change their review? All right, here's the study procedure. So worker submits a product review, which goes into a database. Here's that page again. Then an expert assessor receives an instant message notification that new work has arrived that they should please review. The assessor does that. This leads them to an assessment form. So this is that form you saw before. They read the review and check all the categories that are satisfied, provide a rating, and provide a comment. This lands in the database, where it then gets shown back to the worker, same form, but now it's not editable. So in the self-assessment condition, there's no external assessor, at least none that the worker knows about. And so we just show that form and say, please rate yourself. How well did you do? Now, the important part here to understand is we ask people to rate themselves. We don't use those ratings in our analysis. Right? We actually still have an expert behind the scenes who grades their reviews just like all the other reviews. And the expert is blind to condition. They don't know what type of review they're seeing. All right. And then we go around the cycle. So to assess learning, we just have people do a number of these reviews in a row. You can read all the gory details in the paper that we published at CSCW this year, but just the high-level points. We used Mechanical Turk to post tasks over 1 week. All conditions were running in parallel, so there were no temporal effects. And we ended up analyzing about 105 participants across 3 conditions, 500-something reviews, which cost us about $200. All right, so what are the main findings? Well, both external and self-assessment led to higher rated product reviews than getting no feedback at all. So feedback does help. And there's no significance in the difference between external and self-assessment. Now, before I told you that we gave people the chance, if they received feedback, to change their reviews. The changed reviews are not taken into account here. This is just the first thing they write after writing feedback. All right, second question was about learning. So let's look at learning by calculating the slope of ratings over time from product 1 to product 6. And here we also found that assessment helped workers improve over time. No assessment, no change in ratings. Self-assessment actually had the largest improvement, which was somewhat counterintuitive. So this is not what we had expected. We thought if there's an expert in the loop, people will strive to please that expert and probably do better. So self-assessment was just as effective, if not more, than external assessment. So why would that be? Well, learning researchers have found a number of benefits of self-assessment. So in classroom settings, for example, we found that self-assessment helps to improve performance on essay writing, leads to higher self-direction or agency, and it provides greater intrinsic motivation. And we believe that some of these factors are also at play here. Now, if we look at the data again, so we had this original review, then there was this assessment, and then people could revise their product review. The next question is, what's the difference between the first thing they wrote and the review they wrote in response to their self-assessment or the external assessment? Well, overall, revised reviews were better. Good. This means our rubric actually encoded important principles, and people took them to heart. Now we can break it down by condition. So did having an external assessor have an impact here? Well, it turns out that external assessment encourages more revisions than just self-assessment. So if I just look at my own review and how I might improve it, I am both less likely to edit it, and I will do less work afterwards. So here is where having someone external in the loop really makes a difference. One thing we haven't looked at yet, which is kind of the next really interesting question to look at, is an important limitation of the study. So self and external assessment conditions led more people to drop out.
Did they get paid separately for the first one and the second one, or the same amount no matter what?
They could do as many reviews as they liked.
What about revision? They get paid extra for the revision?
No, they did not get paid extra for the revision. Because the revision was just part of the task, and we did not pay extra for the revision. Which may have been a factor to say, I have to do this assessment, I have to revise my review, this is more work than I'm willing to do, so I'm going to drop out. And it's possible that people who don't take the task seriously, who try to satisfy us, will drop out at higher rates than others. So we only keep the good workers in the loop. So now, what we haven't done yet is the analysis, to what extent are these results due to the fact that we filter out the bad apples versus actually helping the people who were motivated improve what they were doing. So that's kind of the topic for future work, but the quick recap here for this first third of the talk is that shepherding the crowd can improve overall results, ratings over time, and work output per unit of payment. And self-assessment can provide guidance comparable to that of external assessment. And this is really something that should be actionable to many companies in that space today. You don't have to build a big infrastructure to do this real-time work routing and real-time reviewing. If you just ask people to reflect on the work they did and come up with a rubric that allows them to self-assess, you can already reap many of these benefits. External assessment, though, did lead to more revisions, And in future work, we're actually also looking at other types of learning. So instead of feedback, what if you have an apprenticeship model where you can see how someone who's more expert does the task, or you have an expert on call that you can ask for clarification when needed? Yes?
The external assessment and the self-assessment as like contradictory in some way, or do you think that there's a way to pull those together to get the benefits of both?
They are not contradictory. We just completely separated them to have a cleaner study design. But in actuality, what you probably want to end up with is some hybrid where maybe you have an expert who comes in every once in a while and gives overall guidance, and then have people reflect on how they're doing along the way, which is cheaper. So you can certainly combine them. Leslie?
Talk about the checklist use. Was that for both external and internal assessment? So in the previous slide.
Yeah. So let's see. That's many slides ago, the checklist. But so I believe that the results we got are, at least in part, due to the fact that we were able to come up with a good list of criteria for what makes an effective product review. Right? If you cannot come up with that list of criteria because it's unknown, so if you're talking about poetry or art, it may be easy to come up with statements about the surface features of a piece of art, but it may be harder to write down directions for how to be successful. So yeah, I believe that list is crucial.
Was the same list used by both the external and the self-assessment?
Yeah, exactly the same list. We just flipped the wording from an expert said the following to please rate yourself. Otherwise, exactly the same. Wendy?
I'm curious. Well, first I apologize because I have a Chi conference on my brain, and when you have a hammer, everything looks like a nail. Right now, everything I see is Chi related. This looks like something that would be interesting for the Chi review process for papers, right? And so there's an interesting question of anonymity and how do you, is this the sort of thing that you could imagine? Now we've got a known database of people that we can draw from, so it's not the entire world, but we do have a known group of experts who rate themselves in terms of their level of expertise and their interests, and there's this whole matching process. And then you have a hierarchy of reviewers, so you have people who review the papers, and then you have associate chairs who review the reviews, and then you have a secondary associate chair who kind of looks over the first associate chair's reviewing reviews and adds their 2 cents, and then there's a committee that looks on top. So do you see, what can we learn from that would affect the...
Yeah, good question. So can we improve the academic review process through feedback? I believe yes. And so you raise a question about anonymity, but that anonymity is already selective, right? People in middle management, so the associate chairs, already see the identities of people who write reviews. So those would be people who could provide expert feedback on how a review is written, if there are missing pieces, etc. And it may also be the case that if you get them to do that halfway through the process, that their work later on becomes easier because the reviews are maybe more uniform or higher in quality overall. Okay, one more question, then we should move on. Okay, we'll move on. Second topic, real-time workflow monitoring. Okay, so 15 minutes ago, I told you that one of the dominant strategies right now to increase quality or get more complex work done is to create these workflows or crowd algorithms, which divide a complex task into a sequence of microtasks done by workers in some sequence where the output of one step flows into the next stage. So here is the find, fix, verify algorithm that I mentioned, which is an algorithm to leverage the crowd to improve prose. Now, workflow design turns out to be trial and error and labor intensive. So you have to design these tasks for crowd workers. Then you have to implement parallelism or error control to filter out the bad workers. Then you write software that posts these tasks to some other platform that you don't maintain. You run the program. You see whether you get good data back. The kind of latency of finding out that you screwed up is on the order of half an hour to an hour. You identify the errors. You go back to the top. So workflows are effective, but creating good workflows right now is really left to a small group of technology experts. On top of that, designing a workflow turns out to be very domain specific. So if you've gone through writing a workflow for editing prose, that may not help you at all for a different workflow of categorizing images or some other task you want to get done, because the type of work you need to do is specific to the domain. So you have that problem all over again next time you switch tasks. And as I've argued, right now this design step is inaccessible to non-experts. So our research question was, can we have the crowd help us design these workflows? So we built a system called Turk-o-Matic for crowdsourcing complex tasks by asking the crowd itself to design this sequence of work subdivisions and then to do the work and recombine everything into a final result. So the vision here was that we basically give you the Google search box for crowd work where you express what you want to have done in plain text. Then complicated things happen and out pops your intended result. Now, this may have been a reach goal from the start, but it's useful even if you believe that you're probably not going to get all the way there to just see how far you can push in this direction. So our particular approach is to introduce a new algorithm that we call price divide solve, or PDS, which is a divide and conquer strategy to create workflows. So there are 3 steps. The price step, where we ask workers whether a given goal can be achieved for a given price. If yes, we ask other workers to do the work, solve the task. If no, we ask a third set of workers to divide the task into smaller steps and then recurse on each of the steps. And once we have solutions for all the leaves, we ask other workers to combine all the piecemeal solutions into a global whole. The overall story is a little more complex because we have such a high rate of unreliable work. There needs to be additional voting redundancy for each of those steps. All right, let's go through an example. So let's say I would like someone to create a blog with 2 posts. Price step, can we solve that for 20 cents? Crowd says no. Okay, so we go to divide. Divide this task into 2 or more steps. Here is what a crowd came up with. This is a very simplistic decomposition, but at least it is one where each of the constituent parts is now smaller. So now we recurse price. Can we solve each of these tasks for 20 cents? Let's say the crowd says yes. All right, we'll just assign those as tasks. Here may be the solutions that come back. Someone goes out to a blog service, signs up for an account, gives us the info. Another worker is assigned to write 1 post, and you can imagine this post itself is a whole tree of tasks, and so on. And what comes back in the end is a URL that, if you go to, has a blog with the articles written. Okay, so this is the theory. Question, will this work in real life? So can the crowd plan and execute workflows using this algorithm? We ran a whole number of trials, once again on Mechanical Turk, with a wide set of different types of tasks one might imagine. So let me just show you a couple of results. Here's a success. This is an essay taken from an SAT database. May look familiar to some of you. Here's what the crowd did. We have a decomposition into 3 steps. Taking one position, taking the other, reconciling the two.
Very French.
And then the last step was further broken down into, this is maybe not quite as insightful a decomposition, but okay, so we're going to take this reconciliation, break it into separate parts. And what came out here was a reasonable essay, reasonably coherent. I don't think it would have gotten you into Stanford. Now, more interesting probably are the cases where we just ran off the rails. So here's plan a trip from New York to San Francisco that visits 5 interesting places. Here's part of the tree that was generated. And one of those tasks was think about where to go next in Ohio. And then 2 levels down, we had think about where to go next in Ohio. So somehow we lost context of the larger goal that the original requester tried to achieve. Here's a different failure case. This task comes from the CrowdDB paper from Berkeley. List the department chairs of the top 20 US programs in CS. And here's what we got back. So somewhere along the way, we once again lost an important piece of information that a department chair cannot be bought at IKEA. So why does the crowd lose context? Well, there's first that rule of thumb that 30% of the work on platforms like Mechanical Turk will be noise junk. That gets compounded by the fact that we've now built what you could describe as a house of cards, where we have a weakest link problem, right? If something at the foundation is wrong, bad instructions, everything that comes afterwards will be based on those wrong instructions, and that can make the whole enterprise fail. Now, the first thing we thought was, like, okay, we should probably include context. So we designed one of our tasks to actually say, here's what you should do, and down at the bottom, here's the plan made by other workers. Here's the overall goal. Here's what everyone has done so far. Well, the results I just showed you had this feature. So just showing the context alone doesn't seem to be enough. And one of the potential reasons is that because workers expect tasks to be short, the more context you show, the less likely they are to actually read it. Because there's a common assumption of how much work you should be able to go through to just understand what's being asked of you. And if you show a lot more information, potentially complex information, our results so far show that people just will not spend the time. So that led us to a different line of inquiry. If we have every now and again a bad step that can derail the whole process, what if we just have management, someone who watches what's been going on and can intervene at the right time? So we built a set of crowd supervision tools. First, a workflow visualizer, which just lets someone view in real time what this whole chain of tasks is that has been designed by the crowd and what the current status is. And then we have an interactive task editor, which allows these experts, managers, to selectively edit and invalidate part of a workflow. And the last part, which I'm not going to go into much detail here, is the most crucial tasks are the decompositions right in the beginning. If you get those wrong, right, everything else is tainted. So we give people the opportunity, if you already know what the first couple of steps are, just write those down, and we'll let the crowd take over from there. All right, so for the visualization, we introduce this new visualization called task graphs. These are directed acyclic graphs that where the nodes, and encapsulate a particular task. So what is the prompt? What's the status? And if there's an answer, what is the answer that's been provided? And then we color code them whether work has been queued, whether it's in progress, or whether it's been completed. Now, if tasks are split, we use edges to denote these parent-sibling relationships. So these directed solid edges just say, here's a parent task, here are the two subtasks. But now there are two different types of subtasks. Tasks that can be done in parallel and tasks that depend on each other. So we have a different visualization for that, where this dashed arrow indicates that, well, these are both subtasks of a larger task. This has to be completed before you can issue that. All right, with this in place, we can now give a supervisor interactive tools to manage these task graphs. So for example, we have a 3-paragraph essay task, which has been decomposed as follows so far. Now, the first task doesn't seem to be very actionable. Think about the topic. What gets produced that is passed on to someone else? So we can just select that node and say, edit that task, and give more concrete instructions. When you save that, we dynamically compute what part of this task tree is now invalid, kill those tasks, and issue new tasks, and let the crowd take over from there. In particular, what you have to do is you have to get rid of all the child computation tasks. And then if there already was a solution, you have to also walk up the tree and get rid of all solutions that may have depended on this task that you just edited. With this in hand, we then ran a second set of experiments with the same tasks, but had someone watch and intervene whenever one of these task trees ran off the tracks. And here the outcome was no more misses. This was just on a small set, with a small number of interventions. So this is where this project is currently at. And right now it was us, the experimenters, who intervened. But we see, just like in the Shepherd project, where there was now a new job description of someone more expert who could look at work and assess it and provide feedback. Now we have another function of someone whose job it can be to watch these task trees and intervene at appropriate times. And we believe this work can also be assigned to the crowd, but we haven't run these experiments yet. All right, so to recap this part of the talk, Turk-o-Matic is a system that lets requesters harness the crowd to both design complex workflows and then solve them. First experiment showed that if you just run the naive algorithm, sometimes that goes just fine, and other times you end up with tasks that never terminate, and they just get you bad results. And so in response, we built these interactive real-time authoring tools that allow supervisors, managers, whatever you may want to call this new type of job, to intervene and guide as workflows are completed. Why don't we take questions about this part of the work right now before I move on to the last part? Yes?
I was wondering if you have any comments on comparisons between this and the work that Haoqi showed at Kai, which seems very, sorry, I'm not textualizing that for everyone else.
Yeah, I can do that. Okay, so Haoqi Zhang from Harvard and Edith Law from CMU showed a fantastic piece of research at Kai 2 weeks ago, week and a half ago, on travel trip planning. So the example that failed for us actually succeeds in their interface because they introduce a new notion of constraints for the crowd. So where right now in these systems, we assign workers to specific work. We say your task is to subdivide. Your task is to decide whether a task is appropriately priced. So this is pretty far along treating a task just like a function call. The pros of that approach are that with the right quality control mechanism, it's very predictable what you will get. The cons are that you may have workers who are motivated to contribute more, and you're disallowing that by giving them a teeny tiny small task, right? So this kind of looking at crowdsourcing systems solely as an algorithm design problem usually has the approach of making sure the lowest common denominator is still good enough. And I think what Hauchi's work does is it takes this very interesting perspective that we're also adopting that says, well, maybe part of what crowdsourcing systems should do is find the right workers who are motivated and then letting them contribute to the best of their ability. And he then introduces constraints, which are constraints that have to be satisfied for the overall outcome to be valid. And workers can do what they choose as long as, in the end, the constraints are satisfied. So I think that's a really interesting direction to go forward in.
To what extent are the mechanisms based on an assumption of prefix pricing versus payment based on quality?
Yeah,
to do a better result, you get
yes.
more.
Yes. So that's also interesting. So right now, this is an artifact of the platform we use, that we assume there's a fixed price for tasks, because that is the first model enshrined in Mechanical Turk and in some other platforms as well. There actually is a method to pay people based on performance. There's a bonus system. However, that bonus system is not reliably and honestly used by a lot of employers. So a bonus may be dangled in front of you, but then not paid. And there's no recourse for the workers. And basically what that means is that variable price work is not easily done on that particular platform. And what that points out is this constraint that you're trying to get work done, but it happens in a larger marketplace that was not designed by you. And so there are constraints that you kind of have to operate within.
Bjorn, maybe this is one for the end. I'm curious about, it seems like the crowdsourcing community has done a wonderful job of bubbling up a bunch of solutions from the bottom. And I'm interested in where does that line, which is developing a set of techniques for crowdsourcing is different than figuring out the best way to solve problems. And I'm confident that some of those things will line up and not others.
Yep. So there's, I think the reason that you see this bottom-up approach in a lot of the research is because platforms exist that make that kind of work possible. And you can also go the alternative route and say, let's just think about how to solve these problems in a different way, and we build our own platform. But then you're stuck with this other problem that before you can get your research done, you have to build a two-sided market that attracts both employers and workers. And I think that is a difficult thing to do in research. So we're doing some of that at Berkeley, but in the form of a startup company that students have launched that spun out of some courses and projects. And so now, as a company, they have the resources to build that market and get the workers and make decisions along the way of how you actually build the whole system. But it's a much higher and riskier investment, and I think, well, we need more of that work, but it's much harder to do, and hence you see less of it.
Did you mean that, like, difference in how tasks are being designed, or the entire marketplace is being designed?
I meant a slightly different one, which is that if you take the task of have a computer system help me plan a cross-country trip, it may or may not be the case that Turkers are helpful in that ecosystem. And so the top, if you did it top down from a task perspective, you'd ask about, well, what's the best way to get trip planning advice? Which is a little bit different than, can we get the crowd to produce trip planning advice?
Right, and well, I don't want to speak for Hauchi's research, right?
Or even,
so
even your 5 stops across the country.
yeah, so here, I think our vector was a different one, which was, it was not about the task per se, but we were looking for patterns that generalize across a range of different tasks, right? Which, at that point, we can apply any particular expertise of trip planning in particular, because it's just one example of what we would like to support. All right, let's move on to the third project here, community sourcing, where we try to engage local crowds to perform expert work on physical kiosks. All right. Back to the original motivation, this time in slightly different visual form. So the question was, how do we create the possibility of achieving short duration, high volume tasks that require expertise? And I've plotted here this small design space of task duration, task volume, and worker expertise. And you can see where Mechanical Turk and innovation contests and freelancing sites fall. And really, we wonder, does this green subspace exist? Where you have short tasks, high volume, hundreds, thousands, tens of thousands of tasks, and high worker expertise. Now, our proposal for achieving this kind of work is called community sourcing. And there are 3 ingredients. First, bring the crowdsourcing to the crowd. So instead of trying to find the experts online, place a physical kiosk into a community where the right experts already congregate. So if I wanted to ask questions about research directions in HCI, this room would not be a bad crowd to ask for that. Second, pay people in what they value. So paying experts 50 cents is probably just the wrong incentive. However, there are situation-specific incentives that may not have high monetary value, that may still be very valuable to you. For example, high-speed ad-free Wi-Fi at an airport, functioning Wi-Fi at a conference. And third, what this implies is that we're not going to try to build one big market where sellers and buyers find each other, but lots of small, particular targeted solutions. So concretely, what does community sourcing look like? Well, clearly it's a vending machine. Now, this is our first instantiation of community sourcing, which is a 1986 Snackmaster vending machine that vends candy for work. So how do we end up with this particular instantiation? Well, the task that we were looking at was grading computer science exams. At UC Berkeley, this is a very high volume task. We now have about 700 students in our introductory computer science class. So very painful for TAs and instructors right now, but it also requires expertise, right? You have to know about computer science, and questions are explicitly written in such a way that if you don't know about computer science, you're going to get them wrong. So what's a community? Well, let's target other computer science students. What's the right location? How about outside the main lecture hall where big CS courses are taught? And then what's the right reward? Well, we're talking about students, so how about food? So back to our machine. So we modified this vending machine by basically gutting all of the analog 1980s electronics, and then we mounted a touch screen on the face and a card reader. So here's an attract screen that if you walk up to the machine just instructs you to swipe your card. And then the machine presents you with a set of possible tasks, along with the credits you can earn for completing these tasks. We have developed a set of tasks, for example, a general survey task where you just push an XML file to the machine, and we just used it. I believe we got 60 to 100 responses when we just deployed the machine at Chi last week in Austin. So people work on these tasks, get credit, and then different items cost different amount of credit, and once you have enough credit, you just get a standard vending interface and choose which snack or which set of snacks you would like to get. Okay, so we have this idea. How would we evaluate whether community sourcing works? Well, exam grading. So let's generate a set of exams.
Just a quick question. You
Yeah.
do the task while standing
In front of that display?
Yes. So you do the task while you're standing in front of the display, and that has implications for the pricing. So to jump ahead a couple of slides, we price tasks so that the most expensive piece of candy would require at most 5 minutes of work. So we have a price that candy costs. We
It
can.
really works well. You're going to have a line behind you by then. If this is enticing enough, by 5 minutes you'll have a line lined up behind you.
This also happened, yes. We'll get to pictures of that in a minute. Back to exams for now. So we generated our own exam that had 13 questions by just picking and choosing prior questions that were asked on a second semester CS exam at Berkeley. Those exams are public. We took those exams, assembled a new exam, and then we recruited 9 participants. 8 of them just took the exam, and 1 was a ringer. We gave that person the answer key, and they just copied the answer from the answer key. This gives us a way of inserting gold standard questions to check whether people are taking the task seriously or not. All right, so 105 questions were answered in total. On paper, we then took Captricity, which is another Berkeley startup that scans paper forms and crops handwritten answers to specific image regions and gives you a database full of these image regions. And then each question was graded on a 0 to 4 point scale. Here's some example questions. You, of course, all know the answer. Anyways, what I want to point out about this question is some of the questions were close-ended. So in theory, if you had the answer key, you just needed to check. Did they check A or B or C? Multiple choice. Easy. Well, except when it comes to partial credit. So if you don't provide a tight bound here, maybe you should still get a point or 2. And then we had a different set of questions that were open-ended, right, where you just wrote free text. And that required a lot of interpretation on the part of the grader to judge how many points should be assigned. The grading interface is fairly straightforward. So 3 areas on the screen. On the upper left, we have the question. On the upper right, the answer key provided by the instructor. And then here is the cropped area from a student's answer and a grading slider. So we provided basic panning and zooming to make sure you could see all of the answer. And then the way you would grade is you would get one question 1, student 1, assign points, and then you see question 1, student 2, question 1, student 3, so you can rapidly ramp up. So the first time you see a new question is going to take you a while to understand it, but then the subsequent grades can be assigned faster. Rewards in Umati credits, as I mentioned, this was kind of back calculated from how much time we wanted people to spend in front of the machine. Now, what are the results? Well, we deployed, as we said, the machine in front, as planned, in front of the main lecture hall. And we observed students working on the machine, and then teams working on the machine, and then the lines formed. And the lines basically never went away for the whole week, which has two effects. One is a negative effect, that we could have gotten more work done. The other one is a positive effect in that groups of students started to discuss and argue about the questions with each other, which from the department's point of view, that's a win, right? A, you get exams graded, and B, you now have students talking about course material in their spare time. So over the course of 1 week, we had about 325 unique users who created 7,500 answers. So by the end, we had 80 redundant answers for every question that we pushed into the machine.
Hey Bjorn, this is where the large advanced classes are taught, right?
So 306 sort of only fits 150 people. So the lower division classes don't fit. You're right. So
interestingly, the questions you're grading are not taught in this room. It's the upperclassmen
Yes.
who are taking classes in this room.
yes, that is correct. And that is partially made by choice because those students definitely should know the answers. Right? It's also, if we ran a survey before you could grade, 80% of the answers we got came from undergraduates. So this was not, a couple of graduate students skewing the answers. Okay, well, how do we know how good any of these grades are? So we have two comparisons that we set up. First is Mechanical Turk. So we just rebuilt the vending machine interface as a web interface, pushed it out to Mechanical Turk. Our intuition is the expertise is not there. This is not going to work out so well. But then we also hired a whole set of 10 expert graders. So these are PhD students, people who've TA'd the course before, or people who got an A who would be eligible the next semester to be a TA for the course. So what's a good gold standard? Grading is subjective. So how do we compare these different groups? Well, our approach is we define the gold standard as being the median grade of the 10 experts. So we had 10 people redundantly grade this exam, and their median point value, we define that as the gold standard. And then we sample with replacement from each distribution of raters, so Mechanical Turk raters, people on Umadi, the vending machine, and the group that we hired, and compare their accuracy, their agreement, to that gold standard. So that lets you ask questions like, how good is a single PhD student compared to the median of 10 graduate students? Yes?
Is the median any different from the mode for this data?
Is the median different from the mode? So for this particular data set, I do not recall whether we ran the mode. We went with the median because that is a good, robust indicator of central tendency. Whereas the mode can get you into trouble if you have a bimodal distribution. Which actually shouldn't, yeah. So, good question. I can give you the answer off the top of my head. So what are the results? Okay, purple, experts in person, orange, Umadi, the vending machine, and then the other curves are what happened on Mechanical Turk. So first off, a single expert agrees 78% of the time with our gold standard. The vending machine starts lower, but if you crank on the x-axis, redundancy up, so how many raters do you have? Well, at 10 raters, you outperform the single expert. Mechanical Turk, rapidly approaching chance, right? We had 5-point grading scale, so 20% is your chance of just guessing what the right answer is. Okay, so with redundancy, we can do better than a single rater. We probably can't do better than 3 or 4 PhD students, but that's not really an option anyways. At least not at Berkeley, where we have a bit of a budget crunch, and so you're not going to hire 4 redundant PhD students. So now you can do the cost analysis. How much does an answer cost? Well, at a grad student salary, 34 cents per answer, so we timed, but only about 2.3 cents on Umati, and then we used that same 2.3 cents and just said, this is how much you get paid on Mechanical Turk. So now you can do the trade-off and see at the same accuracy, people on the vending machine, the aggregate of people on the vending machine, were 11 cents per grade cheaper than a single PhD student, which turns out to be about 30%. Or you can see at the same price, how much do you gain? In this case, you gain 2% of accuracy. That may be worth your while, maybe not. Some potential biases here. There was a novelty effect. Suddenly, a vending machine was there that dispensed candy for work. Rumors spread, and so we ended up with lines. So we don't know what steady state usage looks like. You can argue that doesn't matter so much because there are situations where you have bursty work that needs to get done and you just drop the machine down and get the work done and you take it back. However, there are other tasks that you would like to run over longer periods of time, and we don't know. We're going to try to find out over the summer. One thing we can say is that by the time we were done, second time the machine ran out of candy, usage was still increasing. So while there's a peak due to novelty, we haven't measured that peak yet. The second bias is this was deployed in a computer science department where people know about crowdsourcing, so that may have generated extra interest. So conclusion, well, for our 1-point example, this worked better than we had expected. You can get higher accuracy or lower cost by finding the right expert community, deploying a kiosk, providing rewards that are relevant to that community, and doing that by targeting the right skills for the right community. And the open questions here are scaling. So Terry mentioned the queues. Well, we can take the queues away by allowing you to do work on your computer before you get to the machine. So it's just a reward distribution mechanism. However, if you do that, and I think you're going to cut out a whole bunch of these social interactions. Arguing about grades, you can't do that if there are no grades and problems to look at the machine, if it just vends candy. And then, yes?
I was just going to say, you might also get a drop in accuracy. In other words, if there's a group of people talking about it, then you're only giving the candy to one person, but there's a group of people doing the work, potentially.
But, so anecdotally, people, when they worked in groups, picked candy that was Skittles, that you could, yes, that you could, distribute fairly.
The cost is going down, so one bag of Skittles deals with 4 people rather than one person.
Yes.
So,
Yeah.
from your cost analysis point of view. But
No, you're correct. Stu?
Couldn't you get a combination effect by allowing people to answer the questions on their iPhone or iPad while in the presence of the machines?
Yep, so this is precisely the path that we're thinking about going down. So you can think of displaying a QR code on the machine, and you have to take a picture. You have to be at the machine to get the task. But then you can pull it on your phone, and you can have parallelism.
You guys talk about ergonomic workspaces. This has got to be about the worst one.
Oh, yes. Yeah, absolutely. Notice that the work that had to be done was mostly in your head, and then you assigned 1-point value. The very next thing we're actually doing, the machine is coming back tomorrow or so back to Berkeley. We're taking that screen out and putting a bigger screen at an angle that is 24 inch, higher resolution.
Yeah, because I noticed you didn't figure into your cost structure the repetitive injuries.
Yeah, so you're absolutely right. This was partially this decision to go with that small screen was it reads very well, right? For someone approaching, it says, this is a vending machine where I normally would push the keys. Oh, there's a screen. It's easy to understand. It's approachable. You don't have to think about what is that model of a machine with these appendages coming out the side with input devices, et cetera. But it absolutely restricted the kind of work you could do. text entry is really painful on that.
Would you think that a good social positioning of the machine would be in student dormitories or graduate student dormitories? Think in a place where hungry students, want to take breaks from their studies. So that's another sort of...
Yeah, and then you got to think, what is the common knowledge that most graduate students in a dorm share, right? Would probably not exclusively, some subset could probably grade CS exams, not everyone. So then there's a question, how do you filter out what tasks you present to whom? We have this ID card swiping mechanism. That actually only was used to track your credits over time. You could have swiped any card with any mag stripe whatsoever. We did not tie into any identity system.
Or something then based on past performance, and then earn the right to grade those exams in your dormitory with that card.
Right, and you can also, you can use your past performance to give you more complex tasks. So the same kinds of things that we saw in the beginning of the task, maybe if you're good enough, you get to review other people's work, right? Kind of, this pops up here again, where in a way we are rebuilding structures, processes from traditional organizations. However, we're rebuilding them for a world where tasks only last a minute and where people can come and go as they please. So you can't just use organizational behavior and transfer it one-to-one to these new environments. Yes?
You were waiting.
Sorry. Another area would be to move into the virtual environment, into Second Life. You can also find quite a few communities of experts and people, and plus distributed far cheaper.
So,
Creating a Second Life vending machine.
that man's virtual candy.
Or Lindman dollars.
So I mean, we are there are other expert communities that exist. So I've studied Stack Overflow before, right, where you have lots of people with expertise in computer science in a virtual community. I think one of the key differences there is that those communities work because they succeed because your work product is visible. I can point to my great answer on how to do X in Python, and other people can see that I'm an expert there. And with exam grading, because of confidentiality, you probably don't want to do that. So there's a separate class of work where you don't want to show to the world what you've done, and then you need other incentives. So it's a good question whether there are other online communities where those incentive mechanisms also work. I believe Crowdflower would say, so Crowdflower is this crowdsourcing startup in San Francisco. Yes, that works absolutely, because some of their channels by which they recruit work is through online casual games, where people buy credit to continue playing the game by doing some of these tasks. So I think some of that work is already happening. Chinmay.
So I'm curious, how necessary is the machine in this case? What if there's just a person sitting there handing out candy for grading parts of your answer sheet, and especially because you say a lot of this work is bursty, so it's much easier to move a human to the spot where you have bursty work than ship a machine there. So how much is the machine and how much is just...
Yeah, but the operating costs of a human are just...
Well,
So this is a good question, right? So what does the machine really give us that... Could you have run that same experiment with a person? That would be interesting to test. I think... So there's definitely this attraction where people know how vending machines work. It's where you go when you're hungry and it's 3 a.m. And so just being able to tap into this familiarity helped. But I do not want to make the argument that all of community sourcing has to involve vending machines. I think that is not the case. And it's one of our questions for future work is what other mechanisms there are. We haven't thought about having people be the mechanism, but we certainly thought about, all of our departments have these public displays. Can you just repurpose one of those?
There's another thing you can do. So you've got people doing this over time. There's a machine there, it's in a place, and people come to it over time.
Yeah.
There's another way of looking at collections of expertise, which you mentioned earlier, which is this is a class, and at this point, if you wanted to ask a question and get some expertise from this crowd, you could do that, and you could do that in parallel in a short period of time. So we've done that where you have, in a conference, for example, you take the last 5 minutes of the conference and you say, interview your neighbor, and we capture the two critical incident technique question. We did a whole bunch of those, and we put those through.
Absolutely.
So you have these interesting, and that's people to people. There's no technology involved. It's just an activity that you run. And so I think there's this really interesting space of this community sourcing that can, there's the virtual versus person space. There's technology assisted or not. There's parallel and over serial and so on. So
I would say thank you for summing up very well a lot of our future work in this area. Yes. All right. I believe we're out of time. Thank you.
I think the fundamental question here isn't just machine as much as
For more, please visit us at stanford.edu.